Hi everybody, we're going to go over midpoints, mid-segments, and some coordinate geometry right now. So for midpoints, essentially it is what it kind of says, right? So I have 2 points, and we're essentially trying to find where that middle point is to kind of go through for that. And so let's say that I have 2 points. I have the point 6, 4 and the point 2, 10. There's 2 big ways of going about this. The first way is very algebraically. And so first I'm going to just kind of sketch these 2 points. So I have 2, 10 would be in the top left, so to speak, and then 6, 4 would be down here. So we have these 2 points. And we are trying to see where that middle point would be. So first is the algebraic question, or kind of way of doing things. We have x sub 1 plus x sub 2 divided by 2, and then y sub 1 plus y sub 2 divided by 2. And essentially these subscripts, this x sub 1, x sub 2, are going from the coordinates that we're given. So I'm going to label this one's x1, y1, and this is x2, y2. And so when I plug in my values here, I get 6 plus 2 divided by 2, and then I have 4 plus 10 divided by 2, and this simplifies to 8 over 2, and then 14 over 2, and that simplifies to 4, 7. So we're going to say that our midpoint is at 4, 7. Another way of going about this that sometimes I like is just looking at the distance. So if I kind of draw a slope triangle in, I recognize that I'm going down 6, and then I'm going over 4. And essentially you just take these values and you divide by 2. So I'm going to do this 4 divided by 2, and I get 2. And then I go negative 6 divided by 2, and I get a negative 3. And so what I do with these numbers right here is that I apply them to the number on the left. And so I'm going to add 2 to my x value, so then I would get my 4, and I would subtract 3 from 10, and I would get that 7. So notice that we got the same answer as we did algebraically. So that is for midpoints. Mid-segments, we take a look at a triangle, and this is kind of nice where we essentially find the midpoints of 2 of the segments, and we connect that, and this is called the mid-segment. And I'm going to label some intersections here, so A, B, C, D, and E. And so we have connected B as a midpoint of AC, and D as a midpoint of CE, and then we connected these 2 points. Again, it's called a mid-segment. And it, again, is nice. So we know that it's a midpoint, so we know that these congruency markings are correct. But what also ends up being true is 2 things here. The first is that, indeed, BD is not congruent, but it is a half. And so if BD would be side length A, then AE would be 2A. So it would be AE would be twice as much. And this kind of makes sense, right? If we have this small triangle up here on the top, and then we have a big triangle with CAE, the relationship is 1 to 2. And these triangles are similar by side angle side similarity, with angle C being a reflexive angle right here. That's true for both triangles, and then the proportion holds for that. Another thing that ends up being true, since we do have similar triangles then, is that angle CBD, so this angle right here on the kind of the top left that I'm scribbling in, is congruent to angle A here down at the bottom left. And since these 2 angles are congruent, by the converse of by the converse of corresponding angles, then we know that BD and AE would be parallel. And so those are the 2 big things where we have the ratio of a 2-to-1 ratio, and then we know that our sides, the mid-segment and the larger side, are parallel. And then to finish up, take a look at some coordinate geometry, and so we're going to plot a couple points. I picked these points before. I'm not just picking these kind of out of thin air, but I have 1, 1, 2, 5, 5, 0, and 6, 4. And so I have placed all of these on the graph: 2, 5, 6, 4, and 5, 0. And I'm going to connect these real quick, and you'll see the fact that it kind of looks like a square. And so it's never a bad thing to think about what it looks like, but now I need to prove what it is. So there's a couple things I need to do for the square. I need to prove that all sides are congruent. And I need to prove that I have 4 right angles. And if I can do that, then I have a square. And so for each shape that we would essentially be taking a look at, you need to make sure that you know the definitions and that you can prove those definitions. To prove that all sides are congruent, I'm going to take a look at the slope triangles, kind of going around this rectangle. So you'll see that I'm boxing it in blue. And I noticed that for each one of these, I have some slopes, right? So I have, this slope is 4 over 1. I have 4, and then this distance is a 1, 4, 1, and 4, and 1. And so if I were to do the Pythagorean theorem for every single one of these, right, I would get my answer of C. And since all of them are 4 and 1, all of the sides are the same. So it would be 16 plus 1 equals C squared. And I would take the square root of 17, and so C would be the square root of 17 for that. So we just did this. Now I need to prove that I have 4 right angles. And so once again, we do take a look at the slopes. You'll notice for that my side on the left side here, my side on the right, I have slopes that are both positive 4 over 1. And then for my slopes on the top and bottom, I have a negative 1/4. And since these two slopes are opposite reciprocals, then we know that these are perpendicular. So again, since they're opposite reciprocals, right, you see this flip and then the change of sign, they are opposite reciprocals and they are perpendicular. So then I know I have 4 right angles. And then by the definition of a square, being all congruent sides and 4 right angles, I can firmly say that this is indeed a square. So hopefully this video helps. Thank you.